welcome back to the Cracking FAANG YouTube channel. Today we're going to be solving Leetcode problem number 35, search insert index. Let's read the question prompt. Given a sorted array of distinct integers and a target value, return the index if the target is found. If not, return the index where it would be if it were inserted in order. You must write an algorithm with big O of log n runtime complexity. So let's look at an example. We're given nums here, which is 1, 3, 5, and 6, and our target is 5. So obviously 5 exists in the array, and it happens at index 2, right? Because this is index 0, this is index 1, this is index 2, and this is 3. So 5 occurs at index 2, so that's why we return 2 here. Otherwise, in this example, where nums is 1, 3, 5, 6 again, and our target is 7, obviously we can see that 7 is not in this array. So if we were to insert it in the sorted order, it would go at the very end because 7 is the largest element out of these ones. And what index does that occur at? So 0, 1, 2, 3, 4. So that's how we got 4. So it's quite simple to solve this question by just looking at the input and kind of deriving it with our eyes. But unfortunately, computers don't work this way, and we're going to need to write some sort of algorithm to actually implement this logic for us. So let's think about how we could solve this in a way that actually corresponds to the requirements we have here. Okay, so we looked at some basic examples and saw how straightforward it was to actually solve them by just looking at it. But unfortunately, like I said, computers don't work that way. So what can we use for our solution? Well, we want to use a binary search, and here's why in case it wasn't obvious to you. The first thing is that we're given a sorted array, right? And we're looking to search for the index of a given value. So we're basically trying to see if a value is inside of a sorted array. Next, we're told that it must be done in log n time. So the only algorithm that will actually let us search through a sorted array in log n time is going to be binary search. So for one, if you guys are new to Leetcode, if you're ever given a sorted array and you're searching for a value or trying to find some index where a value might occur at, immediately think binary search, right? But how do we actually pull off this binary search? Well, typically we have 2 pointers. One, the left pointer will be initialized to the start of the array. So that's going to be index 0. And the right pointer is going to be at the last element of the array, right? So this is going to be the length of nums minus 1. So in our case, with this example, it's going to be at what, right? So this is 0, 1, 2, 3. So the length of nums is 4. So obviously the last index is 3, right? So what we're going to do here is we now set a while loop, right? And what we want to do is basically move the pointers down until we either find our element or basically the pointers cross over each other, at which case we're done because we've searched through the entire array. And the way that we're going to do this is with a while loop, right? So we're going to say while left is less than or equal to right. What we're going to do is we're going to calculate the midpoint. So we're going to basically see which half of the array we want to search. So we're going to say mid, and midpoint is always going to be the left plus the right, integer divided by 2. So in this case, 0 plus 1, integer divided by 2 is 1, right? Because 0 plus 1 divided by 2 is 0.5, which rounds up to 1. So we now have, that our midpoint is going to be this 3 here. So what we want to do is actually check, is the value. So we'll say, let's kind of clean that up. We're going to say nums of whatever the midpoint index is. Does this equal to our target, right? Does it equal to the target? So we're going to check, does 3 equal to 5? It does not. So that means that we have missed the mark with our search here. But let's think about what happens, right? So we have 1, 3, 5, and 6. So we know that the array is sorted, right? Which means that if it's sorted, then everything to the left of 3 must be less than 3. And since 3 is actually less than our target, we will never find our target to the left of 3, right? Because if our target is greater than 3 and, everything left of 3 is smaller, we never have to search this half of the array again because the value will never be here. It has to be somewhere on the right side because those values are greater than 3. This is really important for understanding binary search. So if it doesn't make sense, kind of think about it again. Remember that everything to the left of 3 is sorted because we're given a sorted array. And if 3 is already too small, then all the elements to the left of it will be smaller, and all the elements to the right of it will be bigger. So now with that in mind, we actually don't need to search this entire half anymore. We can search from 3 onwards, and actually we already searched 3, so we can now move from basically 5 onwards and pretend like this is our new array, right? So in this case, since our nums doesn't actually equal to the target, and because our num is actually less than the target, what we want to do is our left pointer is actually too far left. There's no point of searching anything else. So what we're going to do here is our left pointer is actually going to now equal whatever the midpoint index was plus 1, because we already established that 3 is not the target. Therefore, we want to move on to the next one. So what is this index? So 0, 1, 2, 3. So now our left pointer is going to move to 2, right? So we're going to go through our while loop again because 2 is still less than or equal to 3. So now we're going to recalculate our midpoint. So 2 plus 3 divide by 2. So this is going to be 2.5, right? 2.5, and this is going to essentially round up, right? So we'll go to 3, and we'll check our value, right? So we'll go to 6 here, and does 6 equal to 5? No, right? Because it doesn't equal to 5, again, we can apply the same logic, right? Any numbers that come after 6 are going to be too big. If 6 itself is too big and everything to the right of it is greater than 6, then there's no point of searching this array. So we can simply search this way to the left, right? It has to be somewhere, here. And luckily there's only one element left, so we can kind of see that that's where it's going to go. But in theory, if there was more elements, we would want to then search from wherever our left is to basically mid, since the midpoint is pointing here, -1, right? So now our right is actually going to move down 1. So it was currently at 3. Now it moves to 2. So we go through our while loop again, and we're going to see that 2 is less than or equal to 2. So we still continue. So we're going to get 2 plus 2 for the midpoint divided by 2. So our midpoint index now becomes 2. And the value at the midpoint index is 5, which is our value here. So we would return the value 2. So that's the case for actually finding it inside of the array. What happens when the value is not inside the array? So what we want to do in this case is simply let the binary search play out, and either we're going to find it inside here, or we're going to break here, and all we need to do is simply return the left. So let's kind of wipe all of this away and kind of see how it's going to work with this example here. And we'll walk through it kind of line by line, just because this is, a question where I want to explain binary search quite well. So let me just see if I can actually select all this and make it go away. There we go. Okay, that's fine. How do we get, okay, that's fine. Let's just, geez, that is getting messy. Apologies here. Okay, let's kind of clean this up. All right, that should be enough space. Let's stop faffing around. So we have 1, 3, 5, 6, 7, 6, and we're trying to insert 7, right? So we're going to set our left pointer to 0. Our right pointer, again, is going to be the length of our array -1. So this is 3. So again, we're going to do, 0 plus 3 divided by 2. So this is actually, what, 1.5. So this rounds up to 2 here. I think I did my math wrong in the original problem, but that's fine. It doesn't really matter. I can't remember if we round up or down, but it doesn't matter. Anyway, so we check the index 5. So obviously 5 is less than 7, and it also doesn't equal 7. So anything to the left of 5 is too small. We don't want to search it. We only want to search from, to the right of 5. So we're basically just searching this half here. So that means our left moves to 3. So, we'd go through our while loop because remember it's left less than or equal to right. So now we have 3 plus 3 divided by 2 for the new midpoint. So obviously this is 3. So we're going to check the value at the third index, which is the 6. Does it equal 7? No. So what we want to do in that case, we want to move our left pointer up by 1. So the left pointer actually becomes 4. And now we go through the while loop again. But remember, the while loop is actually while left is less than or equal to 4, right? And obviously 4 is greater than 3. So we actually break here. And all we need to do is simply return the left pointer, because now the left pointer will actually be the value that we want to return, which is that index 4. So in the case that we break out of our while loop, we just want to return the left pointer and we're good to go. So hopefully that makes sense. If you've never seen binary search, it can be a little bit confusing at first, kind of figuring out how we move things up. But, you know, it makes sense intuitively. You just kind of need to see it a few times and kind of wrap your head around it, hopefully kind of drawing out the diagrams and explaining how, you know, if it's already too small, then everything to the left of it is going to be even smaller. And then, you know, the opposite is true. If it's too big, anything to the right of that value is going to be even bigger, because remember, we have this sorted array. So let's now go to the code editor and type this up. It's actually relatively simple to code this. I think the harder part is just kind of explaining this and wrapping your head around it. But hopefully you guys enjoyed this, you know, a little bit more verbose explanation of binary search, given that it's an easy question and some of you guys may be new to Leetcode and new to binary search. So let's go to the code editor and type this up. We're back in the code editor, guys. Let's type this up. And like I promised, it's really not that complicated. So let's set up our binary search variables. So left is going to equal 0. And remember, right is going to equal length of nums minus 1. And now we set up our while loop. So we're going to say while left is less than or equal to right. And if this is the first time you're seeing binary search, this is fine. If you've seen binary search before and you're confused on why sometimes it's left less than or equal to right, sometimes it's left less than right, or, you know, some combination, well, the reason for that is we're actually searching for an index inside of the array. Typically, when you're searching for a value inside of your array and you're going to return that value if it's found, then what you want to do is left less than or equal to right. If you're trying to move your index down, typically that's when you're actually using left less than right, but that's for another time. You can just keep this in the back of your mind. If you're returning from inside of the array, then you want to use left less than or equal to right. And in the other cases, you just do left less than right. But again, this is a bit more advanced. Let's kind of stay on track here. So we've set up our while loop. Now we need to calculate the midpoint index. So this is going to be the halfway point between our two pointers. So left plus right. And remember that we use integer division here, because obviously if we get an odd number, then we're going to have, you know, a decimal, and obviously you can't have decimal indexes. So we need to use the integer division operator to truncate that value down to an integer. So we now have our midpoint index. Now we need to check whether the value at the midpoint index actually equals our target. So we're going to say if nums of mid equals to target, then we're going to simply return that midpoint value because we found the value. Now, if it doesn't equal to target, either the target is larger than our mid value or it's smaller, because here we've just established that it doesn't equal to the target if we're actually hitting this point here. So let's do the first case where nums of mid, so the number at the midpoint, is actually greater than the target. And in this case, it means that everything to the right of the midpoint is going to be too big. If the midpoint value is already too big, then everything to the right of it, because remember we have a sorted array, is going to be also larger than the midpoint. So there's no point of us searching that far. So we're simply going to move our right pointer down to the mid minus 1. And obviously we had just searched mid, so we can use mid minus 1 to get the value to the left of it, right? There's no point of us using mid again, because we've just verified that, you know, this didn't fire, therefore this mid value does not equal to the target. The else statement here is going to be the opposite of this case, where nums of mid is actually less than the target, therefore we don't want to search the left half of the array. So we're going to say left is actually going to equal mid plus 1. So our while loop is going to run, and obviously either we're going to return mid here because we found our target, or our while loop will break because at some point right will actually be less than left. So when this happens, remember all we need to do is simply return left here, and that will be our solution. So let me just run this, make sure no little syntax bugs came up, and okay, let me submit this. And hello. Okay, that was weird. Anyway, it was accepted. We can see that it works. So what is the, how do I go back to my code? Okay, cool. What is the time and space complexity? Well, we're using a binary search here, and we know that binary search is always going to be log n time, right? And also the question tells us that we have to do it in log n time. So that's kind of like a hint of what you do there. So space complexity wise, you can see that we actually don't create any variables except for the left and the right pointer, which are just integers. And because of that, it's just going to be a constant space allocation. So that is how you solve search insert position. Hopefully you guys found this video informative, especially for you guys that are new to Leetcode and perhaps are just learning binary search. This is definitely a really good question because it's quite easy to grasp and it's really easy to kind of walk through the binary search, line by line and understand how the variables are changing and how we're kind of moving our left and right pointers up and down. So hopefully, again, you guys enjoyed this little more verbose video. Obviously, it's an easy question. This might seem like a long video, but it was really just me breaking it down piece by piece so you guys can understand how binary search works. Anyway, that's enough rambling because like I said, this video is probably 20 minutes long. If you enjoyed it, please leave a like and a comment. It really helps me with the YouTube algorithm. If you want to see more content like this to help you with your Leetcode journey, then please subscribe to the channel. Otherwise, thank you so much for watching.